Okay, so today we're going to talk about parametric equations, calculus of it, specifically taking derivatives with them, first and second. It's a pretty simple process to follow. It's just the most recent thing we've covered in class, so we need a little more exposure to it. So for all these problems, we want to find dy over dx. First derivative and the second derivative, d squared 1 over dx. So our first example, x equal t to the third plus 1, y equal t squared minus t. So the first derivative is fairly simple. We just take dy with respect to dt and divide by dx with respect to dt. dt cancel, we'll be left with dy dx. So the derivative of y with respect to t is 2t minus 1. X with respect to t is 3t squared. And we can simplify that if we want. So we'll make this 2 over 3t minus 1 over 3t squared. Now we simplify this so it'll be easier for us to find d squared y over dx squared. In order to do this, we have to take the derivative of the derivative we just found. So d dt of dy over dx and divide by dx dt. Just how it works out with parametrics. So we take the derivative of our derivative, and we'll have, I'm just going to switch up the order here. Let's look at the negative signs. 2 over 3t to the third minus 6 over 3t squared all over what we found originally, 3t squared. Simplify our denominators, and we'll get 2 over 9t to the fifth minus 2 over 3t to the fourth. So like I said, pretty straightforward. It's just kind of following the process. And can't forget to divide by dy dx when taking the second derivative.
Can you hold that up for a second?
Yeah, sure. Okay. Right. So our second problem, take a look at x equal t squared plus 1y is equal to e to the t minus 1. So dy dx, take dy dt, which is just going to be e to the t divided by dx dt, which is going to be 2t. E to the t over 2t will be our answer for dx. No real way for us to simplify that, which is a shame. Our product rule for d squared dx, but things. So the derivative of e to the t over 2t is product rule. We do the low times the derivative of I minus I low over 2t squared, and we'll be dividing this entire thing by what we found originally, x dx dt 2t. So in the numerator, see that easy simplification, we pull out 2 to the t, which will leave us with t minus 1. Denominator 2t times 2t is 4t squared times 2t, 8t to the third. So that there will be our final answer for the second derivative. I mean, we could cancel out the 2 and the 8 and also 4, but pretty much the same thing. Next one, we're working some trig functions for the fun of it. X is equal to 2 sine of t. Y is equal to 3 cosine of t. So, for y dx, we take dy over dt, which is going to be negative 3 sine of t. And we divide by derivative of x with respect to t, which is 2 cosine of t, which simplifies to negative 3 tangent of t, 2. So that'll be our first derivative. Second derivative, take the derivative of our dy dx, it's just a constant, negative 3 halves, times derivative of tangent, which is secant squared of t, by the whole thing by 2 cosine of t, which is the dx dt we solved for. Simplifying this expression, we get negative 3 over 4 cosine cubed of t. So we know the secant is 1 over cosine. And that is the simplest form of our answer. All right. One last example of these for you. The floor for questions. We have x equal to t squared plus 1, y equal to t squared plus t. Forward to y dx, 2t plus 1 over 2t, simplify to 1 plus 1 over 2t. And take the derivative of that to find d squared y over dx squared. Derivative of 1 is absolutely nothing, but 1 over 2t, we're going to get negative 1 over 2t squared over 2t calculated earlier, which is negative 1 over 4t to the third. Okay. So that's all I've got for you right now. We'll have more on Sunday's session. It was informative. If you have any questions, ask away.